Good morning, everyone. Today we're going to do trigonometry 11th standard portions. 11th standard portions of trigonometry, which is for CBSE and for ISE students. In general, trigonometry is a chapter that starts at 10th grade. There we learned that trigonometry is study of triangles, isn't it? So in general, there are two approaches to trigonometry. First, we consider that as a study of triangles, and in particular, we learned right angle triangle study in 10th standard. So, study of triangles in which degree measures were used, isn't it? In 10th grade, we learned everything in degree: 30 degree, 60 degree, 45 degree, 90 degree, and 0 degree. Whereas in 11th, we're going to have a different approach. This is called as a unit circle approach, in which the angles are expressed in radian. Unit circle approach in which radian is used in measuring the angles. Now, what is the use in shifting the measurement from degree to radian? The radian is more approximate in values, and it is easier for us to involve this in calculus. So that is why from 11th onwards we're going to learn all the angles which are going to get measured in radian forms. Now, for that, let's start. I know all of you know what is an angle is, but still, let's start with a basic introduction of what an angle is. Let OA be a fixed line. Let OA be a fixed ray of a line. Alright, and it is revolving. So, the line is revolving and rest or stops at OB. So, let the revolving line, say OA, rotate about a point O and rest at OB. Let OA be a revolving line that revolves, rotates, and stops at OB. The path traced by that line, which is measured in clockwise direction, if measured in anti-clockwise direction, is called as an angle. A revolving line rotates and stops at a point. The angle traced by it is a positive angle, and it is measured because it is measured in anti-clockwise direction. Now imagine the revolving line rotates and rests at OY. Let a revolving line OX rotates and stops at OY. The angle measured is in clockwise direction here. So if it's clockwise, it's a negative angle. If it's anti-clockwise, it's a positive angle. A complete rotation is 360 degree, isn't it? A complete rotation meaning imagine a line and it starts and stops over here. This is a complete rotation. A complete rotation is equal to 360 degree. So that means 1 degree is 1 by 30th of rotation. 1 degree equals to 60 minutes. 1 minute is equal to 60 seconds. A radian measure. Now this is where we have to be clear, very clear about. A radian is an angle subtended at the center of a circle by an arc whose length is equal to the radius of the circle. Now let's draw a circle. Let's draw a circle. Let O be the center of the circle. Let OA be the radius. Now, a radian is an angle subtended at the center of a circle by an arc whose length is equal to the radius. Now, let's assume arc AB is also of length R, and I'm going to go join O to this point. So, let's assume this is B. Now, arc AB is of length R. OB is the radius which is also R. OA is also a radius r. How do we find the arc length of a circle? Arc length is equal to theta by 360 into pi r square into 2 pi r. Theta by 360 into 2 pi r. Now here the arc length is r. Theta by 360 into 2 pi r. Right? Now let's assume, since everything is r, consider this as 1 radian. Now r and r get cancelled, right? 2 and 360 degree get cancelled, so that's 180. So that means, and theta I have considered as 1 radian. So 1 radian is 1 radian by 180 into pi is equals to 1. So 1 radian is equal to 180 by pi. 1 radian is equal to 180 degree by pi. Okay, so this is how we convert radian to degree measures. So 1 radian is equal to 180 degree by pi, and 1 degree will be 180 pi by 180 radian. Understood? 1 radian is 180 by pi, and 1 degree is pi by 180. Now, let us consider a few example sums of converting degree to radian, and then I'll do few by converting radian to degree. Fine. So these are questions where we need to convert the given degree to radian. Now, what is the unit conversion here? 1 degree equals to pi by 180 radian, isn't it? Now, so remember this, and this is how we're going to convert all the degree. Now, before I start doing these questions, let's learn how to convert the degrees that we already learned in 10th grade. 30 degree, if 1 degree is pi by 180 radian, 30 degree is what? 30 into pi by 180. So pi by 6 radian. So 30 degree equals to pi by 6 radian. 45 degree will be 45 into pi by 180. So that means pi by 4 radian. 60 degree will be 60 into pi by 180. That's pi by 3 radian. And 90 is equal to 90 into pi by 180. So that's pi by 2 radian. So these are angles that we learned last year in terms of degree. It was in degree. Now we have converted them to radian form. Now let's go to some unknown angles that we are not familiar with, like 25 degree. Well, I think you okay now with this, isn't it? 25 degree is equal to pi by 180. 25 we multiply by pi by 180 because 1 degree is pi by 180 radian. 1 degree equals to pi by 180 radian. So 25 degree is 25 into pi by 180. Now you can leave the answer in pi here. Alright. So when I cancel it, we get 5 pi by 36 radian. So this is how we convert 25 degree to radian. So 25 degree equals to 5 pi by 36 radian. Now, the first questions was the converting some standard wholesome degree into radian form. Now this one is 47 degree and 30 minutes. Alright, not a full form degree, right? We have minutes here. Let's see how to do this. Now 47 degree minus 47 degree 30 minutes, we will write it as minus of 47 plus 30 by 60 degree. Hope you understood that, because 1 minute, 1 degree equals 60 minutes. So 30 minutes is equal to 30 by 60 degree. Alright, so this is minus 47 plus 1 by 2 degree, right? Now this one, let me write it in mixed fraction. I get what? Minus 47 1 by 2 degree. Now let them write this as an improper fraction. So 95 minus 95 by 2 degree. Now let me convert this whole degree into radian. So minus 95 by 2 is equal to minus 95 by 2 into pi by 180 radiant. So with that we get minus 19 pi by 72 radiant. Now the third sum, 5 degree 37 minutes 30 seconds. Okay, we need to convert this into radiant. But before that, we need to convert this into a wholesome degree. Now, first thing is to convert seconds to minutes, then minutes to degree, isn't it? With that, we get them into a full degree form, and then we can convert them into radiant. All right. So, 5 degree plus 37 plus 30 by 60 minutes. That means 1 minute is equal to 60 seconds. So I'm converting 30 seconds to 30 by 60 minutes. Alright. Now 5 degree plus 37 1 by 2 minutes. 5 degree plus 75 by 2 minutes. Now I need to convert the minutes to degree. 5 degree, or I would take it like 5 plus 7 by 2 into 1 by 60 degree. So with this 75, yeah. So with this I get 5 degree plus 5 by 8, 5 by 8 degree, which is 5 by 8, which is 45 by 8 degree. Now convert 45 degree to radiant. 45 by 8 degree is equal to 45 by 80 into pi by 180 radiant. Simplify this, you get pi by 32 radiant. Now the next set of question is converting radian to degree. 11 by 16, but you are not seeing the C terms of power C here, isn't it? That's because sometimes C would be there, sometimes C would not be there. Certain books follow, certain books don't follow that. Now 11, and again we are not finding pi here, right? Because so far all the radian values were in pi, but here it is 11 by 16. That means they must have used pi as 22 by 7. All right, here. So this is a radian question where pi value being substituted as 22 by 7 already. Now we need to convert this radian measure to degree. Now what is the conversion? 1 radiant is equal to 180 by pi degree, right? 1 radiant is equal to 180 by pi degree. And here it is 11 by 16 radian. So we multiply by 180 by pi, and you get, use pi as 22 by 7, 11 by 16 into 180 into 7 by 22. So we get of degree. So answer is 315 by 8 degree. Okay. Now the second one, 7 pi by 6 radiant. And here pi is there, which means they haven't substituted 27 by 7 in the place of pi. 7 by 6 radiant. 7 pi by 6 multiplied by 180 by pi will get this into degree form. Pi get cancelled comfortably. 6 3 times. So we get 210 degree. Understood? So this is how we convert radiant to degree. Sometimes degree, when you want to express radiant to degree, you should be expressing it to the nearest seconds. Let's take one more sum. Let's take its minus 4, which is minus 4 radiant, and we need to convert this into degree. So minus 4 into 180 by pi. This way we get the degree form of it. That will give us 2520 by 11 degree. You take pi as 22 by 7 and you simplify that, you get 2520 by 11 degree, which when you divide, you get it as 229 plus 1 by 11 degree. So when you divide 2520 by 11, stop at the place where we carry with the decimal division. Isn't it? Stop at the place where you get a reminder and when you start with the decimal division. So there write the given obtained answer in a mixed form. So this becomes 229 degree plus 1 by 11 degree. I need to convert them into minutes, so I multiply by 60. So that gives me 229 degree plus 60 by 11. If I further divide it, I get 5 by 11 minutes. So this becomes 229 degree plus 5 minutes plus 5 by 11 minutes. I'm going to convert that into seconds. So this one multiplied by will get in seconds now. So eventually we get 229 degree, 5 minutes, 27 seconds as the answer. And if there is any reminder when you multiply 5 into 60 and divide by 11, just ignore it and round up your answer. Alright. So we did questions where we converted degree to radiant and radiant to degree. Now let's do some other practical questions based on this. Before we move to those questions, there are some concepts that we need to know. One of the formula is L is equal to theta into r. Now let's consider a circle whose radius is r. It's the same proof that I gave you in proving the radian conversion to degree. So arc length of a sector is what? L is equal to 3 theta by 360 into 2 pi r, isn't it? Now we know 2 pi is equal to 360. So L is equal to theta into r. So L is the arc length, theta is the angle, which can be in degree or radiant, and r is the radius. Now, make a note of this particular point. When the question gives us r, when the question has given the r and L info, and we use this formula to find theta, the theta will always be in radiant in that case. But if the question has given the theta in degree form, and they ask us to find either radius or L, then it's not a matter. You convert degree to radiant and do it, or you keep it in degree itself and do it, you still get the answer. So make a mark of this particular point. If L and R is given and you're using this formula to find theta, theta you get will always be in radian form. And when we did the radian sum, you must have noticed that in some of the radian measures are in pi form, some are not in pi form, so it is fine. All right. Now, a wheel makes 360 revolutions in a minute. How many radian does it turn in 1 second? How many revolutions it makes in a minute? It makes 360 revolutions in a minute. Okay, so 360 revolutions in a minute, which is equals to 360 revolution in 60 seconds, isn't it? A minute contains 60 seconds. So that means 360 by 60 revolutions in 1 second or per second. So that means 6 revolution per second. So it revolves six times in a second. And in each revolution, one revolution, it covers 360 degree. In one revolution equals to 360 degree. So 6 revolution equals to 6 into 360 degree. And we want the radiant of that. So radian measure of that is 6 into 360 into pi by 180. Why? Because 1 degree equals to pi by 180 radian, right? So if you cancel this 2 times, so 12 pi radian. So this is the radian that it is made by the wheel in 1 second. All right. Next question. The larger hand of a big clock is 35 centimeter long. How many centimeter does the tips move in 9 minutes? Okay, clock, larger hand and the smaller hand. The larger hand of the clock is 35 centimeter. How much centimeter does it tip moves in 9 minutes? Let's assume that here is where the new position, or here assume here it's where it stops. So how much centimeter the tip moves, which is equal to the arc length, isn't it? Now what we know is only the radius. We have no information to find the arc length because we need two info. We know that L is equal to theta r is a suitable formula that we can use to find the arc length, but we have no information about the theta. Radius is given as 35, but it says that it wants the arc length when the tip moves only for 9 minutes. All right. The angle traced by the long hand is equal, because it makes one rotation in an hour, which means in 60 minutes. The long hand makes one rotation in an hour, so that means it makes one rotation in 60 minutes. So in each rotation it covers 360 degree. So angle traced by the large hand or the long hand in 60 minutes is equal to 360 degree, isn't it? Right? So if I convert 360 to radian, I can say it's 2 pi radiant in 60 minutes, right? So in 1 minute, it makes 2 pi by 60 radiant. And for 9 minutes then, 9 minutes it makes 9 into 2 pi, that's 18 pi by 60 radiant, isn't it? 18 pi by 60, which is 3 by 10 pi c radiant. So the angle or the theta, we found it as 3 by 10 pi. Now let's apply it in the formula. L is equal to 3 by 10 pi into radius, which is given as 35 centimeter. And then substitute pi as 22 by 7. You end up by getting the answer as 33 centimeter. Understood? Next question. Arc of same length in two circles subtend an angle of 60 and 75 at their respective centers. So there are two circles. One is making an angle of 60 degree at the center. Another is making an angle of 75 degree at the center. The arc length is same here, so it says same arc length. So let me consider this to this length, which is L, is same here. L is equal to X and L is equal to X. L1, L2, which is X here because it's same. And let's assume the radius of this one is R1 and this is R2. The question is find the ratio of their radius. Now, L1 by L2 is equal to L1 by L2 is because L1 equals to L2, or we take it as L1 is to L2. Now, what is L1 here? L1 equals theta 1 into R1. So, X is equal to 60 degree into R1, or X is equal to pi by 3 R1, right? And L2 equals to theta 2 into R2. L2 equal to 75 degree into R2. 75 degree we can convert into radian, which will be 5 pi by 12. 5 pi by 12 into R2. Now R1 and yes, L2 is X. Let's put that also. X and X. So R1 equals to 3 by pi X, or 3x by pi, and R2 equals to 12x by 5 pi. So R1 by R2 equals 3x by pi divided by 12x by 5 pi. So what all will get cancelled? Pi will get cancelled, X will get cancelled. So we get 15 is to 12, which will reduce to 5 is to 4. So this is how we find the ratio of the radian. Hope you understood this. Using this video, you can solve the first exercise of your textbook, NCERT textbook, first exercise. If you have any doubt, drop a comment in the comment box. Thank you.